Okay, so we got our second topic, which is the trigonometric and inverse trigonometric equation. So let's get to our first problem. So let me change the color of the font that I'll be using. Okay, so for number one, no, okay. So for number one, okay, we got if we got an equation actually. It's 77 degree plus 0.4x equal to arctan cotangent 0.25x. Okay, so let's just write the equation. So we got here 77 plus 0.4x equal to arctan cotangent 0.25x. Okay, so the first step for this one, we are asked to find the value of x, right? The first thing that you want to do here is you have to get rid of this arctan. So to do that, just take the tangent of both sides. Okay, so taking the tangent of both sides, you'll have here 77 plus 0.4x, right, equal to tangent, okay, and then arctan times cotangent 0.25x. So as you can see, these two will cancel out, okay? And then you will be left with something like this. So 77 plus 0.4x equal to cotangent 0.25x. So the next step here, as you can see, we have here a tangent and a cotangent. And if you have this kind of trigonometric function, you get across with this kind of functions, which are they are reciprocal of each other, right? Tangent is the reciprocal of cotangent, and vice versa. Cotangent is also the reciprocal of tangent. You can now use um, the complementary angle identity. Okay, the complementary angle identity simply says, or you can have this value substitute. So it will become tangent x is also equal to cotangent 90 minus x. Okay, or you can also have here cotangent x is equal to the tangent of 90 minus x. Okay, so using the identity, this identity, you can we can have here something like this. So tangent 77 plus 0.4x equal to replacing cotangent, you'll have here tangent and then 90 minus 0.25x. And then at this point, you can just get the inverse tan or the arctan of both sides, and then the tangent will cancel out itself. So you'll be left with just the values or the angle. So 77 plus 0.4x, 90 minus 0.25x. And simply, if you find the value of x here, just simply transpose and then divide, the value of x here will become, will be also to solve, you will be able to solve that the value of x is 20. Okay. So we can go to the next number. Okay, so for our next problem, we have number 2, right? So the given, we have if sine A is equal to 4/5 and then sine B is equal to 7/25. Okay, 7/25. What is, so we are required to find sine A plus B equal to, so this must have a value, so we'll be looking for that one. If A, okay, if A is in third quadrant, okay, so this should be in Q3 or third quadrant, and B is in second quadrant, so this should be Q2. We have to take note of that. And I think the you need to know that, of course, if we have this Cartesian plane, right? Of course, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 is All of the trigonometric identities, of course, are positive here. Okay, and then here the cosine actually is cosine and tangent. Okay, these are negative, uh, negative, negative cosine, negative tangent, and we have here negative sine, negative cosine, and we have here negative sine and negative tangent. Okay. Okay, so let's find first what this basically means is in quadrant 1 all of the trigonometric trigonometric trigo functions are all positive, and in quadrant 2 cosine and tangent are negative, quadrant 3 sine and cosine are negative, and quadrant 4 sine and tangent are negative. So we'll be able to use that one later on. So first of all, we have to find the values of or the angle A and B. Okay, so the first one is sine A is equal to 4/5. Okay, and then just take the arc sine of the both sides or the inverse sine of both sides. You'll have here A equal to arc sine 4/5, right? 4/5, and then you'll get a value of 53.130, okay, degree. And then for the second one, we have sine B equal to 7/25. So take the arc sine again of both sides. You'll have arc sine 7/25. So this will be equal to 16.2602. Okay. But we have to take note that this angle is in Q3 and this angle is in Q2. Okay. So as you can see in the third quadrant, sine, okay, in the third quadrant we use the uh, sine, right? And in the third quadrant, as you can see, sine is negative. Therefore, this 53.13001, it should be negative. Okay? It should be negative. Okay, should be negative. So okay, this negative indicates that it is in quadrant 3. And for the quadrant 2, as you can see, sine is positive, so we don't have to do anything with 16.2602. That's already fine. Okay, so let's continue. So continuing the problem, we are to find sine A plus B, right? So all you have to do is just substitute the values. Okay, sine, your A now will be negative 53.1301, and then plus, that's the value of A. For the value of B is 16.260. Okay, and then if you use your calculator, you'll get here negative 0. It's not actually exact. I think it's 0.599999 or either 0.601111 something. Okay, so it is close to zero point 0.6. So this will be your answer. So let's get to the next problem. Okay, next problem. So we have for number 3, right? For number 3, we have simplified the expression 4 cosine y sine y times 1 minus 2 sine squared y. So we have 4 cosine y sine y and then 1 minus 2 sine squared y. Okay? Okay, so of course we'll be using a trigonometric identities for this one. We'll be using the double angle identity. So we get a double angle for the double angle identity for cosine, which is cosine 2a is also equal to 1 minus 2 sine squared a. Okay? So as you can see, that part is just this one. Okay? And then we also got a double angle identity for sine, which is sine 2a is simply equal to 2 sine a cosine a. Okay, so let me just rewrite the given. If you rewrite the given like 2, the 4, I'll try to factor it out to 2 times by 2, and then you'll have your 2 I just interchange the position of sine and cosine. So you'll have your sine y cosine y. So you'll be able to see it better. 1 minus 2 sine squared y. Okay, so as you can see, this part will just be sine 2a and this part will just be cosine 2a. Okay, so let's substitute the values. You'll have here 2. So this will become sine 2a, and then this one will become cosine 2a. Okay, so again, using this one, therefore we can say if that is sine 2a equal to 2 sine a cosine a, we can also say that if this is sine 4a, therefore this will become 2 sine 2a times cosine 2a. Okay, therefore the final answer will just be sine, okay, this one will just be equal to this one, sine 4y. Okay, so this will be the simplified function, or the simplification of that expression. Okay, so let's get to the next one. Okay, so let's go to the fourth problem. We have number 4. So for number 4, we have if x cosine, so x cosine theta plus y sine theta equal 1, and then we get another equation, x sine theta minus y cosine theta equal to 3. Find the relationship between x and y. So we need to find a relationship between x and y. So I think the main goal for this one is, the only thing that must be left with the equation is x and y. So we have to eliminate all the trigonometric functions. So how do we do that? So we have to manipulate these two equations somehow so that we can eliminate the trigo functions. Okay? So this is very simple. All you have to do is this one. So square both sides. Okay? Square both sides, then add. Okay? We have to square both sides for the two equations, then add them up. Okay? So let's say this is equation 1 and this is equation 2. So squaring them, so this is square, okay? Squaring them. So if you square both sides, you'll have here, so I'll just do it directly. So you'll have x squared cosine squared theta, okay, plus 2xy times sine theta cosine theta, okay, then plus y squared, and then sine squared theta. And then also square the right side, which is just 1. So 1 squared is just 1. Okay, so for the next one, again, so x squared sine squared theta. Now we get a minus. So minus 2, we got still xy, and we have sine and cosine. So sine theta cosine theta. And then minus, no, it's actually plus, right? Plus. So y squared cosine squared theta equal to 9, right? 9. And then add them up. So we will be able to add these two. Okay, so add. So if we add these two, so you can see the middle term will be cancelled out, right? So we can cancel this one. And then we'll be adding these two. So you can see they have a common factor. So I'll be factoring that out, done one out already. Or you can, so it will become x squared. Okay, factor out that, you'll have here sine squared theta plus cosine squared theta, right? And then plus, factor out the y squared, and then you'll be left with sine squared theta plus cosine squared theta again. And then 1 plus 9, that's just simply equal to 10. And we all know that the Pythagorean identity simply says that sine squared a plus cosine squared A is just simply 2. It's just equal to 1. Therefore, we can say this part is 1, and then this part is also equal to 1. And therefore, we can therefore conclude that we'll be left with x squared plus y squared is equal to 10. So this is the relationship of x and y for this problem. So that will be your answer. Okay, so let's get to the next problem. Okay, we got our last problem for our second topic, which is for number 5, we have if cosine 2x is equal to 2, we have to find the value of cosine 3x. Okay, so we have to find the value of 3x. Cosine 3x, we already have the value of cosine 2x equal to 2. So I think a lot of you will do here is something like this. Okay, so from this equation, you'll have here cosine 2x equal to 2, and then you'll try to find the value of x here. So what you will do is 2x equal to arc cosine 2. Okay, so that will be most of you will be doing, I think. This is also what I did the first time I encountered this problem. But you cannot do this because if you do this in your calculator, the one will be showing up is math error, anything in line with that. So you won't be able to compute this in your calculator because this is an imaginary number. And second reason is because if you're dealing with arc or any inverse of a trigonometric function is the allowable value for this one is just, let's say that is x, the allowable value for that one is just -1 up to 1. But as you can see, this is already 2. Okay, so you won't have a value for that one. So the solution for this one is you have to use again identities to be able to answer this one. Okay, so we already have a value for cosine 2x equal to 2, right? But we all know the identity, the double angle identity of the cosine 2a. We also have a so for the solution of this one, cosine 2x, this is also equal to its double angle identity, right? So with the double angle identity for this one is 2 cosine x. After this is squared, then minus 1. Okay, so this is a double angle identity for the cosine. So from this equation, we can try to find the value of cosine x. Okay, but we already know that cosine 2x is equal to 2. So that will be 2 cosine squared x minus 1. So transpose 1, you'll have 3 equal to 2 cosine squared x, and then 3 over 2 equal to cosine squared x. Therefore, we can conclude that the value for from here, cosine x is just simply equal to square root of 3 over 2. Okay, so we already got the value for cosine 2x and cosine x. So let's try to manipulate down the cosine 3x. Okay. So cosine 3x, if you represent this in another way, you can also represent this as a cosine x plus 2x, right? That's just the same, no? I think it's better if we interchange that. Okay, so 2x plus x. And then using the sum and difference of identity of the cosine, for cosine you'll have cos sin sin, right? So you have cosine 2x and then cosine x minus, this should be minus, and then sine 2x sine x, right? And then next, we already have the value for cosine 2x and cosine x, so we won't have any problem with that. So the value for that is 2, right? Cosine 2x is equal to 2, and then cosine x is equal to the square root of 3 over 2. Oh, this is already The first part is already done. And then for the sine 2x, we have sine 2x. We have, again, we can use the double angle identity, which is sine 2x is also equal to 2 sine x cosine x, sine x again. Okay, so this will become equal to 2 square root of 3 over 2 minus 2 sine squared x, and then the cosine x is already, we already have a value for that, which is square root of 3 over 2. Then we have to be able to somehow manipulate sine squared x, so it will become only cosine 2x or cosine x, but we already have a identity for that, the Pythagorean identity. So using now the Pythagorean identity, 2 sine squared, the Pythagorean identity is sine squared x plus cosine squared x is equal to 1. Therefore, you can manipulate that. You'll have 1 minus cosine squared x times square root of 3 over 2, right? And then this will be equal to 2 square root of 3 over 2 minus 2 times 1 minus cosine squared x. So this will become square root of 3 over 2 squared. Okay, so let me just change this parenthesis into bracket. So this should be a bracket. Okay. Times square root of 3 over 2. Okay. So if you simplify that, you'll get, or you can enter it in your calculator if you want, you'll get 3 over 2 square root of 6. So that will be our answer. Okay. So we can now proceed to the next topic.